Time and Work, Part 2. In this part of Time and Work, we are going to discuss the problems on variation, where there are three parameters involved: number of men, number of days, and amount of work. Let us assume that the number of days are constant. So what will be the relation between men and work? Number of men will be directly proportional to the amount of work. More the number of men, more will be the work produced. Let us say if the amount of work is constant, then what will be the relation between men and days? It's obvious that number of men and number of days are inversely proportional. More the number of men, less will be the required days to finish it, and less the number of men, more days are required to finish the work. If suppose number of men are constant, then what is the relation between number of days and amount of work? They are directly proportional. More the amount of work, more will be the days required to finish it. Let's take an example. 20 men take 10 days to complete a job working 12 hours a day. Find the number of men required to complete a job twice as large in 40 days working 8 hours a day. Now we are going to look at how to build the equation of variation for this particular question. So what is the input here? Manpower is the input. Number of days they are spending is the input. Number of hours per day they are spending is the input. This input should be written on the left hand side of the equation like this. 20 men multiplied by 10 days multiplied by 12 hours per day. This is all input which is written on the left hand side. And the output is the work produced, right? Now, how the second equation will be? In the same way, X number of men working for 40 days and 8 hours per day are expected to do twice the amount of original work. Now, we can substitute the work here as in equation 2 as 20 into 10 into 12. So now we can write this as X into 40 into 8 is equal to 2 into 20 into 10 into 12. Solving this particular equation, we can find out the number of men needed like this, which will come out to be 15. Let's start solving such questions. Problem number 1. If 45 men can do a certain work in 30 days, after 10 days 25 men left the job, then how many more days are required to finish the remaining work? So how we can build the equation here? What is the input? 45 men is the input, 30 days is the input, and the work that they are producing is the output. So we can build the equation as 45 men multiplied by 30 days is equal to the output work. This is our equation number 1. How we can build the second equation now? There are initially 45 men for first 10 days. So we can write as 45 men for 10 days. After that 25 men left. So how many are working? Obviously there are 20 men working for the remaining days. So we can write as plus 20 into X number of days they are working further. And the work produced is same. So this is your equation number 2. As the right hand side of both the equation is same, that is work, we can equate their left hand sides. So I can write as 45 into 10 plus 20 into X is equal to 45 into 30. Solving this particular equation, we can determine the value of X, which comes out to be 45 days. So after 10 days, if 25 men left the job, then the remaining men need to work for another 45 days to finish the work. Problem number 2. 30 men can produce 1500 boxes in 24 days working 6 hours a day. In how many days can 18 men produce 1800 boxes working for 8 hours a day? Now how we can construct the equation? whatever is the input, you write on the left hand side 30 men, 24 days, 6 hours, and whatever is the output, you write on the right hand side, which is 1500 boxes, like this. So 30 men multiplied by 24 days multiplied by 6 hours per day is the input, and the output is making of 1500 boxes. In a similar way, we can construct the second equation as 18 men working for X days and 8 hours per day can make 1800 boxes. Now, what we observe, the right hand side of both the equation is different. Can we make it same? Yes. We can find out what is the input required for one box, like this. 30 into 24 into 6 divided by 1500 is the input required for one box. Similarly, in equation 2, we can find out what is the input required for one box. That is 18 into 8 into x is divided by 1800 is equal to one box. Now, as we observe here, the right hand side of both the equation is same. We can equate their left hand sides and we can determine the value of x, that is number of days. Solving this, x comes out to be 36 days, option A. Problem number 3. 20 workers can finish a piece of work in 30 days. After how many days should 5 workers leave the job so that the work is finished in 35 days? You can pause the video and try this question on paper, and once you have solved it, you can again resume the video to look for the solution. Okay, how the first equation is going to be 20 workers working for 30 days and finishing some work. So 20 workers multiplied by 30 days is equal to the output work. This is your equation number 1. Now let us assume that 5 workers leave the job after X days. So pehle 20 workers are working for X number of days. So how the equation will be? 20 men for X days. After that, what is going to happen? There are 15 men and they need to finish the work in remaining days, that is 35 minus X, because total completion time diya hai 35 days ka in this question. So already X days are over. So how many days are left for remaining 15 men? 35 minus X days are remaining. And the work produced is same. This is going to be your equation number 2. Now as the output work is same, we can equate the left hand side of both the equations like this. That is 20 into x plus 15 into 35 minus x is equal to 20 into 30. Solving this, x comes out to be 15 days. So 5 workers should leave the job after 15 days. In this case, the total completion time for the work will be 35 days. Problem 4. A physics teacher teaches 25% of the syllabus in 20 days with 2 hours of lecture per day. To complete the remaining syllabus in 30 more days, how much time the lecture should be conducted per day? Now in this question, 25% of the syllabus is completed in a total span of 40 hours because it is taught 2 hours per day and that too for 20 days. So to complete 25% of the syllabus, teacher requires 40 hours. Then how much hours are required to finish the remaining 75% of the syllabus? For this, we should simply multiply it by 3. For 75% of the remaining syllabus, 120 hours are required. Now, if this 120 hours of syllabus need to be finished in 30 more days, the question is how much time the lecture should be conducted per day. This is very simple to answer now. If the remaining 20 hours of syllabus is to be taught in 30 days, so lecture per day is 120 divided by 30, that is 4 hours. Option B. Problem 5. One man can load one box in a truck in 5 minutes and a truck can hold 20 boxes. How many trucks are completely loaded by 6 men in 2.5 hours? Now what can be the simplest approach to solve this type of questions? We can write one man in 5 minutes, the output is one box, like this. Now Suppose instead of one man, there are 6 men and 5 minutes are given to them. Then how many boxes will be loaded? Obviously 6 boxes. We have to simply multiply the first equation with 6 to get the second equation. Now, instead of 5 minutes, suppose they have been provided with 2.5 hours, so called 150 minutes. Then how many boxes will be loaded? So we are shifting from 5 minutes to 150 minutes. For that, we should multiply this with 30. So if 150 minutes are provided to them, they can load 6 multiplied by 30, that is 180 boxes. And the truck can hold 20 boxes. So how many trucks will be loaded? So we need to divide 180 with 20. 9 trucks will be loaded. Option D. Next question. 6 men or 8 women can level a field in 42 days. In how many days can 9 men and 2 women complete the same work? Now what work 6 men can do in 42 days can also be done by 8 women in 42 days. So working capacity wise, 6 men are equivalent to 8 women, or 3 men are equivalent to 4 women. Now solve this question either in terms of men or women. Let us say if we decide to solve in terms of women. So 8 women working for 42 days can level the field. This is my first equation. Now it is asked that how many days can 9 men and 2 women require to complete the same work. So 9 men plus 2 women, let us say, require X days to finish the work. As we have decided to solve the question in terms of women, we should convert the men to women's, equivalent number of women's. So 9 men are equivalent to 12 women, because 3 men are equivalent to 4 women. So 9 men are equivalent to 12 women. So I am replacing men with women here. So 9 men are getting replaced by women, and 2 women I am writing as it is into X, and I am equating it with the first equation, that is 8 women multiplied by 42 days. Now solving this particular equation, you can determine the value of X, which will come out to be 24 days. You will get the same answer as 24 days even if you solve this question in terms of men, that is converting women to men. Problem number 7. 3 men and 6 women can do a project in 12 days. 5 men and 6 women can do the same work in 9 days. In how many days can 3 men and 3 women complete the work? Again, in such type of questions, either you need to solve the problem in terms of men or in terms of women. Now, how many men are equivalent to how many women, that is not directly given in this question, that we should determine. Okay, how the equation will be, the first team, that is 3 men and 6 women, can do the project in 12 days. So we can write the first equation as 3m plus 6w multiplied by 12 is equal to whatever is the task, finishing a project. The next equation will be 5m plus 6w, that is 5 men plus 6 women, for 9 days finish the project. This is second equation. Now it is asked how many days are required by 3 men and 3 women to finish the same project. So I can write as 3 men plus 3 women require, suppose, X number of days to finish the project. Now let us say we equate the first and the second equation. 3m plus 6w into 12 is equal to 5m plus 6w into 9. Solving this, what we get further is 36m plus 72w is equal to 45m plus 54w, which will give the further result as 18 women is equal to 9 men, or 2 women are equivalent to 1 man working capacity wise. Now solve the problem either in terms of men or in terms of women. Either convert men to women or woman to man. Okay. Now it is asked that 3 men plus 3 women require how many days? So that is equal to X days. and you can equate this with either equation 1 or equation 2 because right hand side of all the equation is same. Let us say I am equating the third equation with the first equation. आप चाहे तो उसको सेकंड इक्वेशन से भी इक्वेट कर सकते हो थर्ड को. Now, next is conversion. Let us say I am converting again men to women. So 3 men are equivalent to how many women on both the sides? 6 women. Like this. Here 3 men are converted to 6 women, and here also 3 men are converted to 6 women. Now we can simplify this equation because now everything is in terms of women, and we can determine the value of x, which will come out to be 16 days. Thanks for watching this video. With this, we have learned the problem of variation on time and work.